an exercise
Exhibits?
exhibit. Yeah.
Nice. Okay, cool. So you didn't get to ride in any fire trucks?
No,
Um,
no,
it's a shame.
unfortunately.
Yeah, maybe next time.
Yeah.
So what are you gonna do for the rest of the day?
I don't know because I am tired because I didn't sleep, and so probably I will go to sleep.
Okay, that makes sense. Why didn't you sleep?
I have no idea, but I
No idea?
didn't sleep. Yeah.
Maybe you're really excited about the fire trucks.
No, I don't think that. I don't know. I was 2 a.m., 3 a.m., 4 a.m. I said,
Oh man, sounds like insomnia.
yeah.
It's hard. So what about tomorrow? What are your plans for tomorrow?
I don't have any plan
Okay.
tomorrow. No.
Will you have to work on
Nice
your
t-shirt,
project?
by the way. Yeah.
Thanks. Yeah.
Yes, probably yes.
Okay. Yeah. How's it coming? Are you making progress, or are you stuck? Is it going well?
No, it is going well because I asked many things today to the lady that was there,
Okay.
and she was a firefighter. So I asked her opinion.
Nice. Okay. Getting
Yeah.
help is always good. Cool.
Yes, because when you do this kind of project, the firefighting department has to approve them. So
Okay. We would actually just call it the fire department, so the fire department has to approve them.
yes.
Cool. Really nice. And so today we've got these two articles that I was interested in, and one is about. So the question is, if winds reached 500 miles per hour, would it pick up a human? And so it kind of talks about really fast winds. And the other one is about boating on a series of different liquid metals or liquid elements like mercury, bromine, liquid gallium, liquid tungsten, liquid nitrogen, and liquid helium, they're both interesting and kind of funny. Which one interests you more?
The first one? I don't know.
The 500-mile-an-hour wind?
I'm not so good at bowling.
You're not so good at what?
At bowling.
At voting, but you're the only one in class. You have to be able to
No,
vote.
I said at bowling. Bowling?
At voting. Okay. That
Bowling?
makes sense then.
What?
At
Okay.
voting. Yeah, they're similar. All right. Yeah, let's try that then. And
Okay.
we'll have to go for both of them. Your pronunciation definitely won't slow us down very much. Okay, can you read the question?
500 miles per hour. If
Miles per
winds
hour.
reach mile per hour.
Miles per hour.
Miles per hour.
Mhm.
Okay.
Yeah.
If winds reached 500 miles per hour,
Good.
would it pick up a human?
Yeah. From Gray Flynn. And can you read the first part?
Absolutely. Some things.
Hey, Paolo. How's it going?
Hey Joshua, nice to see you again. Fine, thank you. And you?
Doing well. Thanks for asking. Good to see you too. Sorry,
Thank you.
Julieta. Julieta, can you read the question one more time?
If winds reached 500 miles per hour, would it pick up a human?
Okay, and that's our question, Paolo. Julieta, can you read this paragraph one more time?
Absolutely. Some things don't work like they do in the movies. Getting shot doesn't really make someone fly backward. The vacuum of space doesn't make your skin explode.
Vacuum.
Couldn't hear
Can you
you.
repeat vacuum?
Vacuum.
Yeah, good. Vacuum. All right. And any questions on this first paragraph? Okay. Paolo, can you read the next part?
Okay, I can't see. But high wind can definitely pick up a person. In fact, if you were standing in the parking lot, the wind wouldn't just pick you up, it would also peel the pavement from the ground.
Hmm.
Good. Good pronunciation.
Thank you.
Maybe one more time with definitely. Definitely.
Definitely.
Yeah,
Definitely.
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 And Giulietta, can you read the next paragraph?
It wouldn't be strong enough to peel your skin off. Humans can survive blasts of 500 miles per hour wind, which is important because pilots sometimes need to eject from airplanes at those speeds.
Okay. 500 miles. Blasts of 500 mile per hour wind. So, because wind is singular, mile per hour wind. Can you repeat that one more time?
I couldn't hear you. Can you
So,
say that?
yeah, it'd be mile per hour wind in this case.
500 mile per hour wind.
Good. And so if you're talking about something just generally miles per hour, but the wind is a 500 mile per hour wind. A little bit tricky, but good. And Felipe, welcome to class. Felipe, how's it going?
Very good, thanks. In my
Okay,
first class.
good. It's your first class?
Yes, I just coming here right now.
Okay. Welcome to class. Where are you from, Felipe?
I'm from Chile.
From Chile. Okay,
Santiago
cool.
of Chile.
Nice. Good to meet you. And I guess, what do you like to do in your free time? What do you do for fun?
I like going to any place in my bike.
Okay, so you like biking?
Yes, very much.
Nice. Okay. And so we're doing a reading lesson today. Felipe, can you read the question that we're going to be talking about?
If wind or rashes, I, I I don't know how I say that number.
Julieta, how do you say it?
500 miles per hour.
How again, please?
500
500. 500. Will it pick up a human?
miles per hour.
Miles per hour. Right.
Okay.
Will it pick up a human?
Good. And can you repeat reached? Reached?
Reach.
Reached. Reached.
Reach.
Good. It's also in the chat box, in the Verbling chat box. I'll be writing pronunciation, so it looks like reached. So it's a tricky one, but good. Okay. And I think we're now with Paolo. Paolo, can you read this next paragraph?
In the 1940s, the US government put pilots in wind tunnels to learn how they react to high winds. Have you ever been curious what happens to a person's face in 457 miles per hour winds? Well, you can watch a video of one of those wind tunnels test here. The test was conducted at NASA Langley Research Center, where I worked before I started drawing internet comics for a living.
Good. Okay, you did a really nice job. So we're looking at a couple things. The first one's government.
Government.
The U.S.
Government.
government.
U.S.
Government.
government.
Good. You did a really nice job with wind tunnels here, but then when you said tunnels down here, can you repeat tunnel?
Tunnel. Tunnel.
Tunnel. Good. Curious?
Curious. Curious.
Curious. And this again, 457 mile per hour winds, because we're talking about the wind, this specific thing. It is a 430, yeah, mile per hour in this case.
457 mile per hour winds. Mile per hour.
Good. Um, and what was the other one? Conducted.
Conducted.
Conducted. Conducted.
Conducted.
Okay. Good. And does anybody have any questions here?
What does Langley mean? I think it's name
Lang? It's a name, yeah. Langley?
Langley.
Yeah. Okay. And let's have Julieta, can you read the next two paragraphs?
It doesn't look very comfortable. I didn't know chicks could flap like that, but the pilot appears to stay alive.
And the next paragraph too?
I can't see it now.
Really?
Yeah.
Is it too far down?
Oh, okay. Now I can. Luckily, he's trapped into that chair. He wouldn't be able to stand up in those winds. If he tried, he would go flying backward down the tunnel.
Good. Yeah, and cheeks is the only thing. Can you repeat cheeks?
Cheeks. What did I say? Kids.
I think you said chicks or something. Cheeks.
Cheeks.
Uh-huh. Good. Good. And does anybody actually have any interest in watching the video?
Yeah.
Yeah, okay. I don't think it'll be a long one. Oh no. Wanted to do that. So this is a man in 457 mile per hour wind. Can you guys still see that?
Yeah, yeah.
Me too.
Both videos are so silly.
Oh. Oh.
Oh my goodness.
I think he can't breathe.
Yeah, I can't imagine.
Much pressure.
It's a lot of pressure. Oh man.
Oh,
Terrible, terrible. I think if the bone is broken,
Yeah, it's remarkable though. Okay. And so that's that. Um, does anybody have any questions here before we move to the next paragraph?
How he doesn't yell?
He doesn't yell?
Yes, it seems a pretty difficult test.
Yeah. I'm sure I mean, he volunteered for it. He's a pilot.
I like to think that.
Or maybe. What was that?
I like
You'd
to
like to think that?
yes, he's voluntary.
Yeah. Hopefully. Hopefully nobody forces him to sit in really fast wind. I think he's alright though. And Felipe, can you read this next paragraph?
Yes, I can try. High wind is really powerful. In a paper in the journal Weather, J.F.R. McLean showed how to calculate the force of wind on the human body. The calculation on the page 2 shows how far you have to lean to stay upright in the wind of various speeds.
Yeah, in wind of various speeds.
Wind
Good.
of
Can you
various
repeat? Yeah. Journal,
journal,
journal, and
journal,
calculate.
calculate,
Calculate.
calculate, calculate.
And then I think this is McKilvin. McKilvin.
Kelvin.
Yeah, not super important though. And so this is a diagram. And that's just the citation. Okay. And let's have Paolo. Can you read the next part?
when wind speed rises above about 120 miles per hour, it's no longer possible to stay upright no matter how far you lean. You'll start to slide backward across the ground, then quickly go head over heels and start to tumble.
Good. Backward.
Backwards.
And above about 120 miles an hour.
About 120 miles per hour.
Above about. I'm using those
Above
double
about.
prepositions.
Okay, above about
Yeah.
120 miles per hour.
Good. Okay. And any questions here? Okay. Julieta, can you read the citation?
when Hurricane Isabel hit Virginia in 2003, I had the bright idea of standing on skateboard with a poncho held up like a sail, so the wind would blow me down the street. But the moment I got the sail up, the wind fell quiet. Later, I learned that people die from doing that. Oops.
Good. Yeah, and so the die from doing that, it's about a kite sailor who tried kite sailing in a hurricane. Yeah. All right.
Yeah.
Any questions so far? Paolo, can you read this next part?
You wouldn't necessarily be thrown very high. If the wind were perfectly level, you'd tumble along the surface, bouncing against the ground. However, if there were any updrafts, you could easily be lifted up and carried away.
Good. If there are any updrafts? Updrafts?
Updrafts,
Surface.
updrafts, surface,
Good.
surface.
Well done. And questions here. Okay. Giulietta, can you read the next part?
The good news is that 500 mile per hour winds are rare. The strongest hurricanes have wind speeds around 200 miles per hour, with gusts up to 250. Tornadoes can Tornadoes can reach 300 miles per hour.
Mm-hmm.
300 is a far cry from 500. The force from a 500 mile per hour wind is several times stronger than the force from a 300 mile per hour wind.
Good. And Paolo, can you read the little citation?
It's difficult to get accurate measurements of surface winds since those tornadoes destroy most measuring equipment.
Good. Since tornadoes destroy most measuring equipment.
Measuring equipment.
Yeah, good. Measuring equipment. All right, and Paolo, can you read this next part too? Paolo?
Okay, there are a few ways you could experience wind speeds faster than 500 miles per hour. One is to stand on top of a volcano when it erupts. When Mount St. Helens exploded in 1980, the column of ash was blasted outward at 700 miles per hour, which is close to the speed of sound. Wow.
Okay, the column of ash was blasted outward at 700 miles per hour. So can you repeat blasted outward? At?
Blasted outward at
Yeah.
700 miles per hour.
Good. And that's... Giulietta, can you read the next part?
Another way to experience 500 mile per hour winds is to trigger a hypercane. A hypercane is an exotic type of hurricane with 500 mile per hour winds spinning in a very tight vortex just a few miles across.
Good. Sounded great. And Paolo, can you read the next part?
Hypercanes can't exist on Earth right now. Therefore, they require ocean temperatures of about 50 degrees centigrade. No matter how much we warm the planet, we're not going to get the temperature that high anytime soon.
We're not going to get the temperature that high anytime soon.
We're not going to get the temperature that high anytime soon.
Close. Can you repeat temperature? Temperature?
Temperature.
Yeah, it's almost a three-syllable temperature. Temperature.
Temperature.
Close. Look in the chat box. Yeah.
Yes, I see.
Temperature.
Temperature.
Yeah.
Temperature.
Close. You're adding an... Yeah, temperature. So get that E out of there. Temperature. We're not going to get the temperature that high anytime soon.
We're not going to get the temperature that high anytime soon.
Yeah, we really want to emphasize that high, but you did a good job. Good pronunciation. Julieta, can you read the next two paragraphs?
However, there is one way these storms might happen. When an asteroid or comet, coincidentally one about the size of the recent named 4942 Monroe, hit Mexico 65 million years ago, it punched a hole in the crust and left behind a sea of lava. When water flowed back in to fill the hole, it would have been heated by contact with the molten rock. This might have created the conditions for hurricanes to form, and one paper suggests that these storms could have lifted a large amount of dust and debris into the upper atmosphere, thus contributing to a global winter and extinction of the dinosaurs.
Dinosaurs. Can you repeat? Yeah. Dinosaurs, coincidentally.
Coincidentally?
Yeah, coincidentally. Recently named.
Recently named.
Yeah. Debris.
Debris.
Debris. Nice.
Not as.
Yeah, debris. Okay, any questions here?
Debris are fractional rocks.
Yeah, debris, any sort of
Specks.
Yeah, like dust or sand or broken things. So yeah, when a building is collapsed, there will be lots of debris everywhere, just like little bits of broken things, generally. Any other questions? Okay. And Paolo, can you read the comic?
Hypercanes, crater dust, dinosaurs, hot seawater.
Is there anything funny in this?
Yes.
Yeah, the dinosaurs.
The dinosaurs.
It took me a second to notice that the first time I ever read it. All right. And Paolo, can you read the next part?
In short, the answer to Gray's question is yes. 500 miles per hour winds would send you flying through there. But don't worry about that. Instead, worry about is the thing that creates the 500 mile per hour winds. Odds are that's what's going to kill you.
Okay, good. Try to work on these italicized words. So instead, worry about the thing that created the 500 mile per hour wind. Odds are that's what's going to kill you.
Instead, worry about that thing that created the 500 miles per hour winds. Odds are that's what's going to kill you.
Good. Much better. That was great. Maybe flying through the air.
Flying through the air.
Good. And then we've got a comment. And okay. Anybody have any questions about this one? All right, really good job. And so now I can do a little bit of boating.
Oh,
Juliet.
it was boating. Oh man, okay. I thought it was bullying.
Bullying. Wow. No.
Okay.
Okay. All right. So, Julieta, can you read the question?
Extreme boating. What would it be like to navigate a rowboat through a lake of mercury? What about bromine, liquid gallium,
Bromine.
bromine, liquid
Mm-hmm.
gallium, liquid tungsten, liquid nitrogen, liquid helium,
Nitrogen.
nitrogen.
Yeah, nitrogen. Let's have Paolo. Can you read these first three?
Let's take this one at a time. Bromine and mercury are the unknown pure elements that are liquid at room temperature. Temperature. Rowing a boat in a sea
Temperature.
of temperature. Rowing a boat in a sea of mercury just might be possible.
Yeah, rowing a boat on a sea of mercury might be possible. Can you repeat that one more time?
Rowing a boat on a sea of mercury just might be possible.
Good. And temperature. Temperature.
Temperature.
Close. Check out the chat box.
Yes, difficult. Temperature.
Yeah, temperature. Temperature. Temperature.
Temperature.
Yeah, you're doing a pretty good job. Nobody would ever really comment on it. So, good. Giulietta, can you read this first paragraph, or this paragraph?
Mercury is so dense that steel ball bearings float on surface. Your boat will be so buoyant
Good.
that you'll barely make a dent in the mercury, and you'd have to lean your weight into the paddle to get the end of it below the surface.
Perfect. Nice job. Really good pronunciation of buoyant. Okay. And sorry. Just look.
Yeah.
Yeah, that was good. Walk on Mercury.
Mhm.
Interesting. Sorry, that was the video that he'd had. If you be able to walk on it, but it's a long video.
Buoyant.
Buoyant? Okay. Paolo, do you know what buoyant means?
I don't know.
Okay.
So hard.
Buoyant is so like I guess having the property of being able to float. So like it would float so high. So you could think like beach balls are buoyant. So yeah, anything that floats is buoyant. So like something that is buoyant has the ability to float. If you're something that's more buoyant, it has a greater floating abilities. Does that make sense?
Yes. An inflatable mattress is more buoyant than a ball of lead.
Yeah. Or it's more buoyant than steel ball bearings, for sure. Good.
Okay.
And then Paolo, can you read the next two?
In the end, it certainly wouldn't be easy and you wouldn't be able to move fast, but you could probably row a little bit. You should probably avoid splash fights.
Good. And you wouldn't be able to move fast.
And you wouldn't be able to move fast.
Yeah, but you could probably row a little bit. Good. And Giulietta, can you read the next two paragraphs?
Bromine.
Bromine.
Bromine. is about as dense as water, so as a standard robot could in theory float on it. However, bromine is awful. For one thing, it smells terrible. The name bromine comes from the ancient Greek bromos, meaning stench. If that weren't enough, it violently reacts with a lot of materials. Hopefully you are not in an aluminum robot.
Violently.
Violently.
Yeah. Okay, and any questions here?
What is a stench?
Stench? Do you know, Paolo?
I saw on the Google Translator it means smell, bad smell.
Yeah, stench is a bad smell.
Mm.
You're way ahead of us, huh, Paolo? Good. All right, any other questions? All right, so this is bromine, briefly. So we're looking at an aluminum reaction with bromine.
Mhm.
Hopefully this is interesting to you guys as it is to me.
Mm. Oh. Oh.
Ah, yeah.
Huh. All right.
That's nice.
Yeah. Okay. And
Okay.
then, so, yeah. And then, so that's what you would look like if you're in the boat, an aluminum boat. I thought there was actually. All right. Yeah. Good. And Ilkin, welcome to class. Ilkin, how's it going?
Hi, teacher. Thank you. Everything is okay. What about you?
It's going really well. Thank you for asking. Ilkin, can you read the question?
Which question? Okay. What would it be like to navigate a rowboat through a lake of mercury? What about bromine, liquid gallium, liquid tungsten, liquid nitrogen, liquid helium?
Okay, good. So can you repeat mercury? Mercury?
Mercury. Mercury? Mercury.
Mercure. Look in the chat box. Can you see the chat box?
Yes, I see. Mercury.
Okay. Good. Mercury. Bromine.
Bromine.
And then nitrogen.
Nitrogen.
Nitrogen. Nitrogen.
Nitrogen.
Good. Helium.
Helium.
So these are all elements. So talking about navigating a rowboat through different elements. And so we kind of came across mercury, which is pretty safe, and we just watched bromine destroying aluminum. And so let's have, I think we're with Paolo. Can you read this part?
If that's not incentive enough to avoid it, the material safety data sheet on bromine includes the following phrases: severe burns and ulceration, perforation of the digestive tract, permanent corneal opacification, vertigo, anxiety, depression, muscle incoordination and emotional instability, diarrhea, possibly with blood.
Wow.
Wow, very bad.
Yeah, very bad. So a couple of words. We're looking at incentive,
Incentive,
sheet. So sheet,
incent,
this word.
sheet,
Good. And then severe,
severe,
ulceration,
ulceration, ulceration,
ulceration,
ulceration,
digestive,
digestive,
and vertigo,
digestive, vertigo,
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 anxiety,
anxiety,
anxiety.
anxiety,
Good.
anxiety,
Yeah. So
anxiety.
all really bad things.
Yeah,
And let's have Ilkin. Can you read that last little paragraph?
You shouldn't get in a splash fight on a bromine lake. Bromine, what does it mean? Bromine, also a splash. I have so many words which I don't know. What does it mean?
Okay. So bromine. Giulietta, what's bromine?
It is an element. I think it's a metal.
Yeah. I'm actually not sure what it is. It definitely might be a metal. I don't. I think mercury is the only liquid metal at room temperature.
Mhm.
I don't know. I'm not sure. It is bromine.
Mm.
I mean, it's a halogen,
Okay.
apparently. Okay. And splash fight. What's a splash? Does anybody know?
Splash. It's a splash. When you touch the water, roughly.
Yeah. So they're having a splash fight on a boat. So they use their paddles to throw water onto other people. So a splash is kind of like a sort of an explosion of water. He is splashing this person. Does that make sense? Ilkin?
Yes,
Okay.
teacher. I see.
And other questions, Ilkin? Do you have any other questions?
No, thanks. Let us go on.
Okay. And can you read this next paragraph, Ilkin?
Liquid gallium is word stop. Gallium melts just above room temperature, like butter. So you can't hold it in your hand for too long.
Good. Weird.
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 Yeah. It melts.
Sorry.
So gallium melts.
Gallium melts.
And then temperature?
Temperature.
Good. Nicely done. Giulietta, can you read the next two paragraphs? Whoa.
It is fairly dense, though not anywhere near as dense as mercury, and would be easier to row a boat on. However, once again, you'd better hope the boat isn't made of aluminium, because aluminium, like many metals, absorbs gallium like a sponge absorbs water. The gallium spreads throughout the aluminium, drastically changing its chemical properties. The modified aluminium is so weak it can be pulled apart like wet paper. This is something gallium has in common with mercury. Both will destroy aluminium.
Good. You said aluminium, which is how the people in Great Britain say it. In New England, at least, we would say aluminum. This is a word. Yeah. This is a word that has a lot of different pronunciations depending on where you're from. So everybody will yell at me for telling you that. That's how I say it, aluminum. It sounds the most normal to me, but there's a hodgepodge of pronunciations for that word.
This is something gallium has in common with mercury. Mercury.
Mercury.
Mercury. What is mercury?
So, well, Giulietta or Paolo, can you explain what mercury is?
Mercury is a metal that it is used into the thermometer, at least a few years ago.
It's like a chemical element that we can use for measure the temperature and other things.
Yeah. So this is mercury. This is also known as quicksilver, is another word we can use to describe it. Good.
Okay.
Does that answer your question? Okay. And if you guys are interested.
Yes, I am.
I wonder if we can jump this. Huh. Wow. Apparently, they're saying that you can buy it. Wow. Saying it feels like. Interesting. Wow. Okay, so I know you guys can't hear that, but so he used it on a full can, and so by just putting a little bit of gallium on the top, it weakened the structure of the metal enough that the pressure inside caused it to open up. And yeah, he's saying it just feels like cardboard. So that's gallium. Really interesting. Yeah, this next video is just, gallium and mercury working together to destroy aluminum, which I will send you guys in the chat box. So if you guys are interested, you can watch it on your own. Yeah, but that's pretty much what it is. It just gets further. It's pretty interesting. Let's have Paolo. Can you read the next paragraph? Paolo?
Okay. Liquid tungsten is really hard to work with.
Oh, this one first.
Sorry. Like my grandma used to say, don't sail in aluminium boat on a gallium lake. My grandma was a little strange.
Yeah. Don't sail an aluminum boat on a gallium lake. Good. And can you read the next sentence, Paolo?
Liquid tungsten is really hard to work with.
Good. Ilkin, can you read the next paragraph?
tungsten has the highest melting point of any element. This means there is a lot we don't know about its properties. The reason for this, and this may sound a little stupid, is that it's hard to study because we can't find a container to hold it in, or almost any container. The material in the container will melt before the tungsten does. There are a few compounds like tantalum, hafnium carbide with slightly higher melting points, but no one has been able to make a liquid tungsten container with them.
Good. So that's a pretty tricky one. A couple of small things with pronunciation. Properties.
Properties.
Yeah, properties. Material.
Material.
Good. Compounds.
Compounds.
Yeah, compounds. And good. I'm not even sure how to say tantalum, hafnium, carbide.
So compounds means elements, yes? Some elements.
A compound is not an element. Does anybody know what a compound is?
Two elements
Mm-hmm.
or more.
A mixture of elements. Two or more separate elements is a compound.
Yes.
Okay. And yeah, so can you repeat tantalum, hafnium, carbide? Not that you'll ever use that.
Tantalum, hafnium carbide.
Good. Really good. Good job.
Mhm.
Okay. Does anybody have any questions here? Okay. And Giulietta, can you read these next two paragraphs?
To give you an idea of how hot liquid tungsten is, I could tell you the exact temperature that it melts at 3,422 Celsius degrees, but a better point might be this. Liquid tungsten is so hot, if you dropped it into a lava flow, the lava
You broke up a little bit. We lost Ilkin. Can you repeat that?
Liquid tungsten is so hot, if you dropped it into a lava flow, the lava would freeze the tungsten.
Good. Yeah.
So
and
lava is hotter, right?
Lava is pretty hot, yeah. But so it's just not at 3,422 degrees Celsius.
Mm-hmm.
All right. Any questions here? Okay. Paolo, can you read the next paragraph?
Needless to say, if you set a boat on a sea of liquid tungsten, both of you and the boat would rapidly combust and be incinerated.
Okay. Both you and the boat would rapidly combust and be incinerated.
Both of you and the boat would rapidly combust and be incinerated.
Nice. Good job. And can you read this next part? Paolo?
Okay. Liquid nitrogen is very cold.
Nitrogen.
Nitrogen. Thank you. Liquid nitrogen is very cold.
Nice. And Giulietta, can you read the next paragraph?
Liquid helium is colder. Helium is colder, but they are both closer to absolute zero than to the coldest temperature in Antarctica. So to someone floating on them in a boat, the temperature difference is not that significant.
Good. Any questions here? Maybe Julieta, significant. Significant.
Significant.
Yeah. Good. And Paolo, can you read this next part?
A Dartmouth engineering page on liquid nitrogen safety includes the following phrases: violent reactions with organic materials, it will explode, displace oxygen in the room, severe close-to fire, suffocation without warning,
Okay. Organic.
organic, organic,
Suffocation.
suffocation,
Yeah, suffocation. Good.
suffocation.
And Julieta, can you read this part?
Liquid nitrogen has a density similar to that of water, so a robot would float on it, but if you were in it, you wouldn't survive for long.
Good. Paolo, the next paragraph.
If the air above the nitrogen was room temperature when we started, it would cool rapidly and you and the boat would be smothered in a thick fog as the water danced out of the air. This is the same effect that causes steam when you pour out liquid nitrogen. The condensation would freeze you quickly, covering your boat in a layer of frost.
Good. So smothered.
Smothered,
Condensed.
condensed,
Good. The condensation. Condensation.
condensation, condensation.
Yeah. Perfect. And any questions here?
Yes, I don't remember smothered.
Smothered. So it's like heavily covered would be smothered. There's like if you smother somebody, it's like you cover them with something. Sometimes it could be like a pillow. It's kind of an idea of suffocation, but you can also smother a food in a sauce. So you could say like a steak smothered in cream of mushroom sauce. I don't even know. But smothered is like heavily covered. Any other questions? All right, Giulietta, can you read this part really quickly?
The warm air will cause the nitrogen on the surface to evaporate. This will displace the oxygen over the lake, causing you to asphyxiate. If the air on the nitrogen were both cold enough to avoid evaporation, you would instead develop hypothermia and die of exposure.
Hypothermia.
Hypothermia.
And asphyxiate.
Asphyxiate.
Questions here? Okay. And Paolo, can you read this next part?
Liquid helium would be worse. For one thing, it's only about 1/8 as dense as water, so your boat would have to be 8 times larger to support a given weight. We're gonna need a bigger boat, but at least the shark isn't a puppet.
Good. Giulietta, can you read the next two parts?
But helium has a trick. When cooled below about 2 degrees Kelvin, it becomes a superfluid, which has the odd property that it crawls up and over the walls of containers by capillary force.
Capillary. Capillary forces.
Capillary forces.
Yeah.
It crawls along at about 20 centimeters per second, so it will take the liquid helium less than 30 seconds to start collecting in the bottom of the boat.
Paolo?
This would, as in the liquid nitrogen scenario, cause rapid death from hypothermia. If it's any consolation, as you lay dying, you would be able to observe an odd phenomenon.
Mhm.
Okay.
Superfluid, okay.
Julieta, the next part.
Superfluid helium films, like the one rapidly covering you, carry the same kinds of ordinary sound waves that most materials do, but they also exhibit an additional type of wave, a slow-moving ripple that prolongates along the films of helium. It is only observed in superfluids and has the mysterious and poetic name third sound. Wow.
Good. Exhibit
Exhibit.
and propagates.
Propagates.
Exhibit.
Good.
Propagates.
Paolo, can you read the next two parts? Paolo?
Okay, your eardrums may no longer function and wouldn't be able to detect this type of vibration anyway. But as you fall to death to the floor of a giant boat, your ears would be filled, literally, with a sound no human can ever hear, the third sound. And that, at least, is pretty cool.
Good. And so if you guys haven't looked up anything about superfluids, they are very cool. And there's some interesting YouTube videos online. HOS is the second sound. HOS, Julieta?
No, I mean, how is the second sound? Because I
Yeah.
don't know. Yeah.
It's a heat transfer by wave-like motion. Yeah,
Okay.
interesting. Okay, thanks for coming in. Hopefully you enjoyed class. I was kind of like these ones. Paulo, Julieta, both good to see you guys, and hopefully have a good
Thank you.
weekend.
Thanks.
Thank you, Joshua. Thank you, Julieta.
Bye, guys.
Bye-bye. See you.